Right. To understand this attribute, how it behaves when we tune them, when we don't tune, how it behaves, and to understand these things, we have this topology. We can learn almost all attributes from this one topology. That is how we have designed it. For testing, we will use this network 6.6.6.6. This is the network that 1.1.1.1 wants to reach. From here, we should ping 6.6.6.6. And you know, they are not in same autonomous system. They are in different autonomous system. The reachability need to be provided, but we don't have one common IGP protocol here. Each autonomous system is different organization. BGP 10 may be your company. BGP 30 and 20 may be your ISPs. BGP 40 may be your remote site. So these are all different autonomous systems. But one good thing is we have one common protocol end-to-end BGP. It's one common protocol BGP. But you remember earlier we spoke like we have two flavors of BGP, IBGP and EBGP. It is good that we have these two flavors. If not, we need to redistribute, which will consume a lot of processor, which will also spoil the attributes. See, when you redistribute from BGP to OSP, what happens? You lose all the attributes. But when we have the same protocol as IBGP and EBGP, the attributes are preserved. The attributes that is configured on router 6 will be carried as BGP update till that left hand side router 1. It's the same protocol which is giving and taking from other autonomous system. So there is no need for redistribution. Automatic redistribution happens between EBGP and IBGP. The attributes that need to be carried or carried without any redistribution, that makes the originality to be preserved. Fine. Now let us go here to router 1 consoles. We'll start from router 6 left hand side, right hand side. In router 6 we are advertising show IPBGP. We are advertising this network. For local origin, the weight will be given higher automatically, which we saw in the previous class. Now we want this network to be available in R1. For that, first let us go and check whether we are learning it on R5. R5. Show IPBGP. Yes, R5 has the 6.6.6.6. R5 has learned it from two different sources. You see, this can be learned straight away from here. How many hops? Just one hop. It can also learn like this. That will be how many hops? 1, 2, and 3. 40, 20, 10. Let's see. 40, 20, 10. So you are learning both from router 2 as well as from router 6. Router 6 as well as from router 2. Which one will it be using? Because we did not set any attribute. Because we have not set any attribute, it is going to pick based on AS path, because here for both the paths AS jumps are not the same. They are not equal. One is shorter, another one is longer. I just showed you. This is shorter. Going where 6 is shorter. This is longer, 3 hops. That's why you see here the greater than symbol is only for router 6 next hop. When we check this by typing show IP route BGP, you can see it is going via router 6. eBGP administrative distance is 20. So it goes via router 6. Next. So we got router 5, 6.6.6.6, and it is going via this way. Now, my question to you is, someone should answer me, is this 2 next hop a reachable next hop or not? Is it a valid next hop or not? For router 5, is this 2 reachable address?
Yes.
Yes. So when I ping, they are going to ping. That's a way to check it. I just asked you to wake up from the sleep, tiredness. They are directly connected. Of course, they will ping. Now you see, if the valid next hop, if you have a reachable next hop, by tuning the weightage, you can change the path selection. Right now, the path selection is via router 6. I showed you. It's via router 6. The reason is it's just one hop. It's just one hop. So it's going via this gateway. You see, this gateway is seen in the routing table. But for some reason, you do not want to go via that router 6. Why, you know? The bandwidth is very low. The bandwidth here in this link, now for example, let's assume this is you and you are connected to 2 ISP. This is one ISP, this is another ISP. With ISP 2 you have more bandwidth, let's say 100 meg. With ISP 1 you just got 512 KB. BGP will not focus on bandwidth. So BGP will focus only on these attributes, you know. It won't focus on bandwidth. But you want R5 to go via this way. to reach this internet. Let's say this is the destination, internet destination. We can achieve this by simply changing the weight. See? By simply changing the weight, we can change this. And it is local to the router. So this one router, if it wants to go via router 2, by simply changing the weight, we can achieve it. Let me show you it by changing. R5 router BGP autonomous system is 30, no? 30. Router 5 is in 30. Neighbor. See, this is the neighbor whom I want to give more importance. So I say neighbor. For you, I give weightage. What is the default weightage now? It's 0. I'm going to say thou shalt have 50. I gave more weightage. Let's check now. Show IPBGP. It is not changed yet, but you can force it to get changed immediately without waiting by clearing IPBGP star soft. Just clear it, and now you will see weightage. Changed. See, earlier it was 0, now it is 50. And as soon as you see, before when it was 0, the greater than symbol was not here. It was via router 6. But now this is switched to the long path. You see? You see why the reason we switched to this one? Because the bandwidth is high. So some reason you will have like what we have now. Now the reason what I am giving for switching it to router 2 to reach 6666 is bandwidth. Likewise, you may have some other reason in your production to achieve that requirement. You may use weight as the attribute. I just showed you how to change the weight from 0 to 50 so that this itself will become a tiebreaker. Earlier, this was the tiebreaker and we did not configure anything. One path was shorter than the other, and because there was a tie in all these above, it was picking this. But because I changed the first attribute, now there is no need for BGP to refer attribute 2, 3, 4. First is always the best. Whichever attribute that breaks the tie first is the best. It won't look into the next attribute. So now none of these attributes are considered because the very first attribute itself is a tiebreaker. So if I'll take you to the routing table, earlier it was .6, but now show IP route. Now it is via 2. It goes via router 2. When you look this, it looks like, it's not really good to go via router 2 because this is just one hop. Why you are taking this long route? Yeah, but in the real world, this is what we do. 512, because we have given more money to this ISP. He's got more bandwidth for us. Instead of going through the narrow road where I have more traffic to send, I cannot send via this path, no? There will be packet loss. Maybe what I can do, you know, I can take some traffic, small tiny traffics like voice, video. I can leave it default. I'll match the rest of the traffic and I do what I did now. For the rest of the traffic, go this way. Voice and video, you may go this way. Now you can do those things by using route map. I'll show you that example after understanding this basic attribute tuning. That is advanced attribute tuning. We will see that later. How to send few traffic on the left, few traffic on the right, few traffic on the straight, few traffic on the back. So we understood how to set weight. Next is the local preference. So to understand local preference, let's change the scenario. We are going to learn local preference using this autonomous system 10. For that, I want the 6.6.6.6 to come to autonomous system 10. Let's go to 6.6.6.6 autonomous to 10. Check whether 10 knows about 6666. I'm on router 3. Show IP route BGP. I don't have any routes. Why? Show IP BGP summary. Do I have a neighbor? I do have a neighbor. But I'm not having route. Why router 5 is not giving 6.6.6.6 to router 3? It is because for router 5, please focus this one important. For router 5, 6.6.6.6 is via whom? Via router 2. Router 2 is in which autonomous system? 10. Router 3 is in which autonomous system? Answer me, please. 10. It won't give. Why? According to router 5 says I'm going via the path to reach 6666 via 10. 10 only gave me. Who gave this route in the routing table that I'm having? Autonomous system 10. Then how can I give update to 10 again? I took it from autonomous system 10. If I give to autonomous system 10, then he gave me and I gave him, loop will occur. I cannot give. Sorry, I'll give, but he will not take. Router 3 is not taking it. There's one solution for this. What you can do is, our old scenario is over, no? The wait scenario. So whatever you configured here, let's go and remove it. And you remove this wait that you configured here. Router 5 will use this path learned from 40, and there won't be any problem in giving to router 3. Let's see. I'll go to router 5 to remove the wait. Removed. Clear IP BGP star soft. Show IP BGP. I'm looking for the 50 to get removed. After it gets removed, you will see this route reflects in router 3. Okay, see, it's back to normal. Now it started using 6 because this has become 0. Earlier it was 50, we set it to 50, now we have revised it, removed it. Show IP BGP, show IP route BGP. You see now it's going via 6. There's no problem for router 5 to give it to router 3. Where is router 3? Router 3? Earlier it was not learning any prefix from there. But now it has learned a prefix. And what is that prefix? And this is the prefix. So router 3 has got a route to reach 6.6.6.6 and it is via router 5. Alright, likewise, router 2 also should be having the route for 6.6. Show IP route stuff. So for 6.6.6.6 it is going via router 4. Show IP BGP. It goes via router 4. For router 2 to reach 6.6.6.6 to go via router 5 and 4, the number of hop is same. Look at this. These two are reachable next hop. So this is satisfied. Highest weightage. There is no highest weightage. Both have got equal weightage. So that is a tie. Next is the local preference. Higher is preferred. But there is no local preference because both are coming from eBGP. Local preference will be seen only if you are learning from IBGP. In order to decide whether to go via this IBGP or that IBGP, I need local preference. If you want to understand local preference, you need to check here whether to go via this IBGP or this IBGP. You should not check here because here it is eBGP. This and this are eBGP. So that's the reason why I took this autonomous system 10 to understand local preference. Yeah, so we are on router 2. Router 2 will not use local preference to decide because it has got two eBGP neighbor. Next. Prefers the route originated by the local router. Is there any local router in router 2 and 3? No, there is no next hop 000. Both in router 2 and router 3, there is no show IP BGP. There is no local origin. So this is also not applicable. Next thing it will check is the shortest AS path according to router 2. Both the AS path is same, 2 hops away. Now after this comes the MED, right? Sorry, local or lowest origin code. Is anything advertised or redistributed? Both are advertised. I don't see redistribution. You see, both are I. If you have a question mark, it would have preferred I and ignored question mark. But there is no question mark. There's only I. So there is a tie in this. Now it prefers the lowest MED. There is no MED set. Prefers eBGP over IBGP path. In our topology, if you see, this is also eBGP, this is also eBGP. So that is not a tiebreaker. Prefers the path to the closest IGP neighbor. Means metric should be less. to reach this, if metric is 10, to reach this, if this is also having same metric, then there is a tie. Of course, we have gig Ethernet everywhere, so the cost is same. And first of all, we don't run any OSPF, so don't worry about that. This is not the problem. This is the reason. Prefers the oldest route for EBGP path. Oldest route for EBGP path. This may be the reason, may not be also, it may be next one also, you see. Prefers the oldest means according to router 2, if this is an older neighbor, later came this neighbor, so it prefers this one. But I started all the routers at the same time. Let's assume both came and formed neighbor at the same millisecond. Assume. Then what it does, it prefers the path with the lowest neighbor router ID. Of course, this is the reason. The router ID of this is 5.5.5.5. The router ID of this is 4.4.4.4. For router 2, which one has got the lowest router ID? Router 4. Router 4 is in which autonomous system? Router 20. That's the reason why I see it goes via 20. Router 4. Why? Because of the router ID, lowest router ID. Lowest router ID. Where is the router ID seen? Let me show you. Show IP BGP neighbor 1024. We have to see 1024.04. 1024, you see, router ID is 4.4.4.4. For the next router, for 1025, it is 5.5.5.5. That's what the loopback interface address we have in router 4 and 5, which is automatically taken as the router ID. Fine. So we understood. Now the path is preferred by router 4. The reason is the router ID, the lowest router ID. If I change the router ID to 44, 44, 44, 44 in router 2, it will switch via router 5. Router 2 will switch the path via router 5. You want to see that? Let me change. Router BGP 20. BGP router ID 44. Clear IP BGP start soft. Let us go to router 2 now. Router 2, earlier it was having, now it goes only via router 5. Give some time for the route to be learned. Wait some time. It has to learn the route from router 4. Okay. See, it has learned the route from 4 as well as 5, but it's going via 5. The reason is, now the reason is this is the oldest one. This came just now. Even if they both come at the same time, this is going to be selected because the router ID is 5555, whereas here router ID is 44, 44, 44, 44. See, let me show you. Show IP BGP neighbor. You see, for router 4 it is 44. For router 5 . For router 5 it is simply 5555. Yeah. Alright, so what we have got now is the reason to say why it is going via 5 is discovered. Now router 2 is going via router 5 and router 3 is also going via router 5. Earlier router 2 was going via 4, but we changed the router ID, so it switched to router 5 now. Next is what? Next we'll check on router 1. Show IP BGP. Summary: I have two neighbors. From both the neighbor I learned the prefix. And what is that prefix? I know it is 6.6.6.6. And now what it says is, listen, it says I learned from router 3. Router 3 says it learned from router 5, which is in autonomous system 30. Router 2 also now goes via router 5. You remember that we changed the router ID, so it's not going via 20, it is going via 30. So both go via the same AS path. Both AS path is same. Please understand. Same. It's not same number of hops, it's the same hop. If I remove the router ID and put back the default router ID, then you will have same number of hop. It may not be same hop. You see, let me go and remove the router ID that we set on router 2. Let's bring it to the default. Router BGP 20. Okay, sorry, not in router 2, router 4. Router 4 only I changed to 44, no? Let me remove this router ID and put back 444. We have to wait some time for the updates to go and check on router 2 first. Show IP BGP. Now router 2 says I'm also having a route via router 4. But preferred is router 5. Preferred is router 5. Yeah, the oldest is also router 5. I have to clear BGP here then. Clear IP BGP. Start. I'm doing hard reset. Now there are chances for router 2 to go via router 4 using the router ID. Yeah, it goes via router 4. Now let us go back to router 1. Earlier on router 1 it was showing same AS numbers, but now it won't be same. It's 20 here because router 2 is taking the path via router 4, which is BGP 20. Router 3 is taking the path via router 5, which is BGP 30. It's okay. Now we have same number of hops. There is no shortest AS path. Let's start from the beginning. Weight is same, tie. Local preference is same, tie. MED is same, tie. There is no local origin. Tie. Shortest SPL, origin code, MEDs, tie. eBGP is preferred over IBGP. No. Both are IBGPs. There is no eBGP. Isn't it? You see? Both router 2 and router 3, both are IBGP for router 1. We are checking on router 1. Both are IBGP. Next. Prefers the path through the closest IGP neighbor. There is no closest IGP neighbor. Both have got gig Ethernet. So if cost is 1 here, this is also going to be 1 only. IGP cost, OSPF cost. BGP will refer OSPF cost to see which IGP neighbor is nearer. It is same. So there is a tie again. Prefers the oldest eBGP route to eBGP. There is no eBGP actually. Both are eBGP. Again the lowest router ID. See who has got lowest router ID. This guy has got lowest ID. It prefers the lowest router ID. It has used the lowest router ID. See. We got the next stop as 2222 because we said next stop self when we configured IBGP. That is our earlier previous day class. Now, our aim is to understand local preference using this topology. Local preference is immediately after wait. We finished wait. We are in local preference. To understand local preference, we have come this far, and this is the topology. Right now, it is going where this way. But by changing the local preference, see, please understand. Right now it is going where this way. What if I have only 10 meg connection, whereas here 1 gig connection? I want all the traffic in this. I want all the traffic. I just got 2 routers, including router 3 routers. I want all the routers traffic to go via this direction because the bandwidth is very high. To achieve that, weight is not sufficient enough. Why weight is not sufficient? If you set weight here, only this router can go this way. This will still go via this way only. So, what we need to do? We need to set local preference on this router so that even this router will follow this path. Local preference is advertised to all the neighbors in the same autonomous system. Now, router 1 has got the same local preference. That's a tie. If I set more than 100, like 200, if I set 200, this greater than symbol will switch to here. Right now, show IP route BGP. I got route via 2222. This will become 3333333333333. If I change the local preference, there are 2 ways to do it. One, to make this bigger, you can make this smaller, right? You can leave like this. So you can go to router 2. You can go to router 2 and make 50, or leave this 100 default. Go here and change it as 200. Any one you can follow. Let me follow the first one which I said. I'll go and change the local preference of router 2 to 50. So the router 3 will be bigger. Right now, both router 2 and 3 are equal. When I go and change the local preference, router BGP 10, BGP local. Local preference. Default local preference. Default so it is BGP default local preference. So I'm giving local preference 50 for router 2 and clear IPBGP star soft. Let's go to router 1 and check now. Router 1, look at this, the difference. Earlier it was 100, but now I made this bigger by making this smaller. Earlier it was here, now it is switched to here. Earlier the routing table was showing the next hop as 22222, but now it will show 33333333333333333. Yeah, it shows 3. So we have just changed local preference for one of the edge router. In our case it's router 2. I change the local preference to 50 so that this will be seen as the bigger one, and all, even router 1, when you do changes here, even router 1 decides to go this way. That is what local preference is. Weight is locally significant to one router. Local preference is locally significant to one autonomous system. You may have 1000 routers. All 1000 routers will go via router 3. Yeah. So we have seen only the basic configuration, basic tuning, not advanced tuning of weight and local preference. We have seen basic tuning of weight and local preference. The next one is local origin. You know about this attribute, you know about the shortest AS path, you know about the origin code. But still we have something to play with these things in the advanced topic. So in our next class we are going to repeat again weight and local preference in an advanced level, and then advanced level of AS path tuning, MED, origin, all those things will continue. Right? Any questions? Please ask if you have questions.
No questions.